Ta-da! Just like that, we're on the last day of this unit. All right, this is geometric sequences and series. So when you're looking at geometric and arithmetic, we had a common difference where we were adding the same number or subtracting the same number to get from one term to the next. In a geometric sequence, you're multiplying by the same number in order to get from one term to the next. Okay, so there's a common ratio between the two. So some examples of that would be like 2 to the n, that's geometric. 4 times 3 to the n, that's geometric. If I had something like 1, 4, 9, 16, that is not geometric. Okay, so my question to you is x squared, negative x cubed, x to the fourth, and negative x to the fifth geometric? Okay, so go ahead and think about that for just a minute. So according to my calculations, if I take a term and divide it by the previous term, I continually get negative x. Okay, even if I was to use the third and the second term, I would still get negative x. So yes, this sequence is geometric. Okay, another formula that you don't have to memorize because you get a formula sheet for your quest. The nth term of a geometric sequence is a sub n equals a sub 1, your first term, times r, your common ratio, raised to the n minus 1. Okay, so that's going to be the formula that you're going to use. So as we take a look at this next question here, it says, write the first 5 terms of the geometric sequence whose first term is 3 and the common ratio is 2. So I want you to go ahead, use the formula that a sub n equals a sub 1 times r raised to the n minus 1, the one that was in the box above. Come up with a general form for the sequence, and then go ahead and find the first 5 terms and then plot them, and we'll see if we agree when you return back to the video. Okay, do we all agree with what Mrs. Croft has here? I have terms of 3, 6, 12, 24, 48. Notice that each time you're just multiplying by 2, being the common ratio there. Now, what kind of function does it look like we're representing here? Good, an exponential. Nice, good work. All right, let's take a look at the next question. It says find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So go ahead and find that general form for me, please. Okay, so you should have a general form of 20 times 1.05 raised to the n minus 1. Everybody agree? It's so easy to work with you guys when everybody agrees with me all the time. Okay, next thing you're going to do is you are now going to find me the 15th term of this geometric sequence. Okay, if you'll notice that since our common ratio is 1.05, we had a little bit of a decimal value going on here. So you should have had 39.59. 863, if you continue on, it was like 19888 after that. Okay, all right, next one. So this one I'm going to give you, here's the first 3 terms. Find me the 12th term. We should have come up with a value of 885,735. Yes? If you think about it, you're multiplying by 3 every time. So by the time you get up to the 12th term, multiplying by 3, your numbers are going to increase drastically. All right, let's take a look. What do we got here for the next question? The 4th term of a geometric sequence is 125, and the 10th term happens to be 125 over 64. Find the 14th term. Now, in a geometric sequence, remember, they can alternate positive, negative, so that's why that they're giving you the disclaimer here that you assume that all of your terms in the sequence are positive. Okay, so this one's a little bit different. We need to figure out what our common ratio is. So I'm going to go with the fact that a sub 10 is equal to a sub 4 times the common ratio, and that common ratio would be used 6 times. And the reason that I got 6 was because I said, well, it's the 10th term minus the 4th term. Okay, so the 10th term is what happens when you take the 4th term and multiply it by the common ratio 6 times. Okay, so what we're going to do here is fill in what we know. So we know that this is 125 over 64. We know that this is 125 and times r to the 6th. Okay, we're gonna divide that by 125, which is the same thing as multiplying by 1 over 125, which is gonna reduce those. So we have 1/64 equals r to the 6th. Now, how am I gonna figure out my r value in this case? So there's two different ways. You can either raise both sides to the 1/6 power, which will cancel out that 6, or instead of that, you can take the 6th root of both of those. And if you happen to take the 6th root of 1/64, you end up with a common ratio of 1/2. Okay, so there's your R value. Now, if we're going to find the 14th term, we now have our R value. We don't have our first term, but we really don't need it in this case because we can use the same process that we just did. We can say that the 14th term is the 10th term times the common ratio raised to the 14 minus 10. Okay, so let's fill in what we know. We don't know the 14th term, that's what we need to find. The 10th term is 125 over 64. Common ratio is 1/2, and we're going to raise that 1/2 to the 4th power. Okay, so if you want to go ahead and calculate that for me, dun, 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 that's 1/16. Then we have 1. Okay, so it's going to end up being 125 over 1024. I appreciate those of you that have your calculators by your side helping me out here. Okay, and so that's another way. Now, if you didn't want to do it that way, you could have found the general form. Because you have your common ratio, you would have had to have then in turn found the first term and then found the 14th term, but that would have just added extra steps, but it certainly would not have been incorrect. All right, finding sums. So again, formula that's given to you here, we have the sum. It's 1 minus r. So if you look here, here's like in sigma notation, and then really what it is, it's the first term times 1 minus r to the n all over 1 minus r. Again, formula given to you on your quest, so you don't have to worry about memorizing it. So what I'm going to do here is it says go ahead and find the sum. So I'm going to go ahead and use the formula, and the formula reads that I should use a sub 1 times 1 minus r to the n all over 1 minus r. All right, first term. Got to figure out what the first term is. So we put 1 in for I. 1 minus 1 is 0. Anything raised to the 0 power is 1. So it looks like the first term is just 4. Okay, so we're looking at the first term being 4. And then our common ratio, one thing that I want you to notice about this formula here, there's your first term. That's how come that was 4. And then that number there that's being raised to the exponent, that's your common ratio. So I already have those values. I could have technically pulled them right from my formula. So this is going to be 4 times 1 minus 0.3 raised to the 12th, because if you'll notice your lower limit is 1, your upper limit is 12, all over 1 minus 0.3. Okay, those of you that are still helping me out with your calculator calculations, can you go ahead and put that into your calculator for me, please, very carefully. A couple tricky things in there that your calculator might not like, such as following order of operations. All right, so you should have come up with 5.714. Okay, so that would have been the sum. Had you found each individual term, added them all up, you should get 5.714. Skip that next one. We don't need to do that one. Okay. Last one here. Now we have an infinite geometric sequence here, or series here. So meaning that the terms are going to go on forever. So there's actually a sum for this. Notice that if your ratio is less than 1, this is when this works. So you'll actually get a value. If your R value is less than 1, you can actually have a sum. If it's greater than 1, obviously you're not going to have a sum because your number is going to keep growing indefinitely. Okay, so the first one here, we're going to take our first term, which happens to be 4, and then we're going to divide it by 1 minus your common ratio, which is 0.6. So that's going to give us 4 divided by 0.4, which is going to give us 10. Okay, so if you found, basically what happens is you keep adding numbers and it's basically just going to add up to 10 when you get done. Okay. Now the next one, if you keep adding them, notice that each time you're just adding a 0.3. So this is really like 3.3 repeating. Okay, your R value in this case is just going to be 0.1. You're just multiplying by a tenth every time. So it's not, I mean, if you look at the pattern on this last one, you're just going to get 3.3 repeating. It's not going to change. It's just going to keep adding threes to your value. So you just end up with that. So if you go ahead and put that into your formula, a sub 1 over 1 minus r, go ahead and tell me what you get. Surprise! It's 3.3 repeating. Okay, so in this case, it was pretty easy to see the pattern there. All right, that was the last video for this unit. Guess what's coming up next? Your quest. That's right, your 6-question quest. Yes, I am going to throw some curveballs in there, but you have all your information. You have the basic skills that you need in order to take those curveballs and hit them out of the park. I expect lots of hundreds on this one, and then your reward for doing all your videos, doing all your Math Excel, taking a test right before February break is that you have no math to do over February break. All right, I'll see you guys in class for your quest.